Welcome to our review on forces in collisions. So when we're talking about collisions, we're talking about having potentially a large negative acceleration. So one of the most common scenarios we'll be asked about here is in the case of a car crash. So hopefully every time you get into a car you put on your seatbelt. It is obviously law these days, but some people still choose not to. The whole idea of your seatbelt is to actually allow you to come to a slower stop, so that when you're wearing the seatbelt and the car comes to a sudden stop, you continue to move forwards for a little while and the seatbelt's going to stretch to bring you to a slower stop. Now that's important in terms of the forces that are exerted on your body. Once you've had a crash, then the seatbelts do need replacing because they've been stretched and they don't go back to normal after that, so they won't be effective a second time. If, however, you've chosen not to wear a seatbelt and the car comes to a sudden stop, you're going to continue to move forwards at the original speed of the car, and generally speaking that ends in a very messy way, so put your seatbelts on. Even though seatbelts are designed to be a safety feature to protect us from injury, there are of course some injuries that happen even when you're wearing a seatbelt. So if the negative acceleration is very large, you can suffer from what's called a compression injury, or your internal organs could become damaged as they collide with the ribs as they come to a stop against them. So what we find is when cars travel quickly, the forces involved can be quite large. So we in the UK have a maximum speed of 70 miles an hour on our motorways, even though quite a few people seem to ignore that and think it's more of a guideline rather than a rule. The downside to that is the faster you go, the greater the force you experience in the case of a crash will be, and therefore the more injuries you will sustain. So what we find is that the actual force that you will experience from a collision is dependent on the amount of time it takes for that collision to come to a stop. So what we can do in the design of cars to try to counteract these forces is to increase the time it takes for that car to come to a complete stop. So we've built in things like a crumple zone, which is where we've actually built in materials of different densities on the car itself, so that some are designed to basically squish up in an accident. So that means the car is going to take longer to come to a stop, reducing the forces acting on the people. We also have airbags which have the same idea. They inflate so that rather than your head hitting the steering wheel, the dashboard or other hard surfaces, and therefore coming to a rather rapid and messy stop, you can hit something that will allow you to deflate it slightly and therefore come to a slower stop, thereby reducing the forces acting on you. Hopefully at the end of this video you can explain the dangers caused by large decelerations and talk about ways that the car manufacturers have actually tried to reduce these forces.